Okay, so here's a couple of things to keep in mind as you start on page 139, problem 1. The first thing is that when you're expressing ratios in simplest form, you need to make sure that the units are the same. So you need to make sure, before you get started, that you've got the same units so that you can drop the units out of the ratio. So if we look at this problem, for example, we're comparing 750 grams to 1 kilogram. Well, in order to do that, I have to figure out how many grams 1 kilogram is. Unfortunately, because I've had a great science teacher, I know that 1 kilogram is equal to 1,000 grams. So now I can go ahead and compare 750 grams to 1,000 grams, and I can write it as a ratio, 750 to 1,000. Now I can think about simplifying the numbers a little bit too. They're both divisible by 10, so that leaves me with 75 to 100. And 75 and 100 are both divisible by 25, so that can leave me with 3 to 4. And so there I'm in nice simple terms. Another thing that you might want to think about when you're expressing your ratio in simplest forms is you don't really want to have fractions, because a ratio sort of is a fraction, then you've got a fraction of a fraction, and that just seems complicated. So there's a great way to simplify fractions in a ratio, and that's by just multiplying them by the LCM. So if I think about this ratio, 1 to 1/3, I want to clear out this fraction here and have them both be whole numbers. So I start by finding the LCM of 1 and 1/3. And if I think of 1 as 1 over 1, the LCM is clearly going to be 3 here. So now I'm just going to rewrite that ratio, and I'm going to multiply both sides by the LCM. I'm writing this 3 over 1 as a fraction because I'm multiplying it by a fraction. And so to help me cross cancel, I can see I've got 1/3 times 3 over 1. So if I cross cancel, 3 cancels to 1, 3 cancels to 1, and I'm left with 3 times 1, which is 3, to 1 over 1, which is 1. And now all of the fractions are gone. We can do the same thing multiplying by the LCM for mixed numbers. We just have to turn them into improper fractions first. So 4 times 2 is 8 plus 1 is 9, so that's 9/4. And that is compared to 5 times 3 is 15 plus 3 is 18/5. And so I'm going to find the LCM of 4 and 5, which is just 20. And so I'm going to multiply now both of these fractions by 20. Again, I'm going to write it as a fraction because I'm going to be multiplying it by a fraction. So here I've got 18/5 times 20 over 1. And I'm going to do a little bit of cross-canceling, so I'm getting out my red cross-canceling marker here. So 20 cancels with 4, and that leaves me with 5 in the numerator, 1 in the denominator. And 20 can cancel with 5 also. They're both divisible by 5. So 20 divided by 5 leaves me with 4, and 5 divided by 5 leaves me with 1. And so now going back to my standard color, I've got 5 times 9, which is 45, to 4 times 18, which is 4 times 10, or 40, plus 4 times 8, which is 32, so that's 72. The LCM method works with decimals too. We just have to spend a little bit of time to figure out what that least common multiple of the least common denominator would be. And so if you think about the place values, we've got the units place, which would be here, it would be a 0, tenths, hundredths, thousandths place. And this one is units, tenths, hundredths, thousandths place. So since they both go to the thousandths place, let's just multiply them both by 1,000. So 0.280 times 1,000 as compared to 0.182 times 1,000 would be 280 to 182. And now I can just go about simplifying by finding something that I can, a factor that's common to both of them. And they're both even, so they're both divisible by 2. So 280 divided by 2 is 140. And 182 divided by 2 would give me 91. And then both of these guys are still divisible by 7, so I can divide 140 by 7 and I'll get 20. And I can divide 91 by 7 and I get 13. And there you go. Nice, simplest terms for your ratios. Great, so I hope you enjoy the rest of the problems on page 139.